Hey guys, all right, this video it's on solving rational equations. We only have 4 examples left. So are you guys ready? Let's draw a line, okay? Example 3, remember we did example 1 and 2 in class already. So if you were absent, please find the video on YouTube and take notes on your own. So remember step 1, we have to factor, find common denominator and restriction. So we are going to take x minus 1 all over. This one is factorable, so we can write x plus 2 times x plus 1. And if you are still struggling with the factoring by now, please come and see me at tutorial so I can help you. Plus 3x over x plus 2, and then equals to x minus 1 all over x plus 1. We are going to find LCD and restriction in the same step, okay? Lowest common denominator. So you have an x plus 2 here and an x plus 2 there. So I am going to take 1 from that, okay? Then you have an x plus 1 and an x plus 1. Same thing, we're going to take 1. So that's your lowest common denominator. Now, take that lowest common denominator and then we're going to set equal to 0. So right away we are going to have restrictions. Let's write it over here. X can never ever be -2 and -1. And box that up. So what do you do with each restriction? I mean, not restriction. What do you do with the lowest common denominator? So I want you to think back. What do we do with each denominator that we found? The lowest common denominator. What do we do with it? We will multiply it to each and every term. Okay, so I'm writing the first term back. And as you can see, I'm writing the factor term. So I know in a moment I will be able to reduce or cancel. Oops. So this is my LCD. All over 1. Remember, you can write all over 1 if you wish. And if the numerator has multiple terms, then put parentheses around it. Then plus 3x over x plus 2 times your LCD, which is x plus 2. I'm going to try to squeeze that in there because I'm writing way too big, over 1. And then equal to, let me just erase this line, equals to x minus 1 all over x plus 2, then times our lowest common denominator of x plus 2 times x plus 1 all over 1. Okay, now I'm going to draw that line because I just wrote way too big. You can make it smaller if you want. So now this is the fun part. You get to cancel. X plus 2 is going to cancel out. X plus 1 is going to cancel out. This denominator has 2 terms. You can also put parentheses around those and those and those and those. Okay. Then x plus 2 is going to cancel. X plus 2 is also going to cancel. Oh shoot, you know what I did? I wrote this one wrong. This is supposed to be x minus 1 over x plus 1. So do not cancel that one. Okay, so now cancel the other one. We are going to cancel x plus 1 and x plus 1. Okay, so now let's distribute the remaining pieces. Over here, this is the only piece that's left. Over here, this piece and that piece. Over here, this piece and that piece. So what I'm going to do is I'm going to write all the remaining pieces first. Okay, x minus 1. That's the piece that's left. Plus this one says 3x times x plus 1. Those are the 2 pieces left, equals x minus 1 times x plus 2. Okay, so now I want to be organized. I want to write those pieces first before I distribute. Okay, so now let's distribute. 3x times x is going to be 3x squared. 3x times 1 is going to be positive 3x. X times x is going to be x squared. X times 2 is going to be 2x. Negative 1 times x is negative x. Negative 1 times 2 is now negative 2. Let's see if I can combine like terms on each side and then set equals to 0. So over here I have 3x squared. We have a 3x and an x. That will now make it a 4x. And then a minus 1 on this left side. Over here I have an x squared. Then you have 2x and a minus x would now be just a single x left, minus 2. As you can see, this is a quadratic, so what you want to do is you want to set one side equals to 0. What that means is you want to move some of it to one side, whatever side you pick, just pick a side, okay, and then set it equal to 0. So now I'm moving everything to the left side, as you can see. 0, 0, 0, 0, 0, 0. So this is 2x squared. Now this is now a positive 3x, negative 1, and a positive 2 is now a positive 1, it equals to 0. So now we need to factor it out and solve. Okay, so this is now how you need to see if it's factorable. I'm definitely going to be, I need to write a lot smaller on the other parts, but right now, let's just deal with this. So let's see, ready? Factorable or not. On the top, 2 times 1 is 2, on the bottom is 3, so now in the we have 2 numbers, multiply give you 2, and add give you 3, so that's 2 and 1. So rewrite this as a 2x squared plus 2x plus 1x plus 1 equals to 0. We are going to factor by grouping. So we are going to take out a 2x. We are left with an x plus 1. Over here, we're going to take out a positive 1, and then x plus 1 equals to 0. So the factors are x plus 1 times 2x plus 1 equals to 0. Then set each part equal to 0. X plus 1 equals to 0. 2x plus 1 equals to 0. On the left side, we know that x has to be negative 1. That is nice and easy. Over here, move the 1 over. So now we have 2x equals negative 1. Divide both sides by 2, so x is negative 1/2. Before I get so happy and box it up and call it a day, I have to go and check my restriction. What were the restrictions? I've done so much work that I forgot the restrictions. Okay, so let's, okay, so x earlier said x can never ever be negative 1. Oh my. And x can never ever be negative 2. I have an answer that's a negative 1. I cannot keep it. Okay, so make sure we only keep one answer, which is x equal to 2.5. That's the only answer that we can keep. So again, be very mindful what our restrictions were, so we can decide what to keep and what we cannot keep. So now we're going to try the same thing for example 4, but I'm going to try to write a lot smaller. Okay. Example 4 says x over x minus 1 equals 1 minus 1 over 1 minus x. Before I even do anything, guys, I'm going to write this in order. So this is going to get 1 over 1 minus 1 over negative x plus 1. Okay. So the reason I want to write in order is because when I factor that, I want to take out a negative 1. So this is going to be right 1 x over x minus 1 equals 1 over 1 minus 1 over, I'm going to factor a negative 1 from here. If I factor a negative 1, I have an x minus 1. As you can see, if I have an x minus 1, this is the same as my other denominator, so I don't have to do a lot of work. And in mathematics, 2 negative is now a positive. So if you look at it, this is so much easier than you thought. It's x over x minus 1 equals 1 over 1 plus now 1 over x minus 1. So if you look at it, your lowest common denominator, it's just x minus 1. So the restrictions right away is x can never ever be 1. Okay, so box that up. So we're going to multiply each and every term by an x minus 1 since we only have one LCD. So I'm going to write it backward. Ready? So x over x minus 1 times my LCD, which is x minus 1, I'm going to write as a fraction. Okay, just like that. Now, I wrote x equals a 1 over 1, but technically you don't have to do that. You can just write 1 times x minus 1. Now, if you like to do 1 over 1, it's still up to you. Like, that is fine. Okay, there's no difference divided by 1. You can write it and you don't have to. Then plus 1 over, remember this is your LCD, so let me just fix that color so it's consistent. So 1 over, my original was 1 over x minus 1, okay, times LCD was x minus 1 over 1. Then I'm going to put quantities around this so I know when I cancel, I know I'm going to cancel the whole thing. So here's what we're going to do. We're going to cancel that, okay, cancel that. So the first term, I'm left with just an x. The second, I'm left with an x minus 1. And the third, I'm only left with an plus 1. So here, what happens is I'm going to simplify a negative 1 and a positive 1, so those are gone. What? You have x equals to x? Okay. Well, as you can see, x equals x is always true, right? Or even, this is what you can also do. You can go, well, I want to set equals to 0. Sure, you can set equals to 0. That means 0 equals to 0. So what's happening is this is all numbers, okay? So when you have an x equals to x or 0 equals to 0, that's always a true statement. So how do we write this answer? Then what we write is all real solutions except where the denominator was excluded. I know, right? This is so cool. So your answers would be all real solutions or all real numbers except when x was restricted at 1. So we can totally box that up. So again, when you have x equals to x, 0 equals to 0, 5 equals to 5, then you can, that's always a true statement. Okay, now you're listening to this on video, this lecture on video, because I'm probably not here. So feel free to ask your teacher or your sub to pause a little bit. Now let's go to the last two example 5. And as you can see, I wrote so much on this, on the space here. Let me see how much space you guys have. Actually, you guys have a lot. So what we're going to do is we are going to draw a line right there, so I know not to invade the space. Okay. All right. So what we're going to do is find the common denominator, lowest common denominator. Ready? Lowest common denominator. Let me erase all the previous stuff from example 3. There you go. Ready? All right. LCD. Looks like x plus 2. It's all by itself, so I'm definitely going to take that. Then you have an x minus 2 from each one, so just take one of those. Okay, so right away, state the restrictions. X can never ever be negative 2 and positive 2. And make sure we are mindful about going back and check that once we have our answers. So take each of our piece and multiply by our lowest common denominator. We can put it over 1 if you want, and then put parentheses on things that have multiple pieces. Minus, and I need to write small because as you can see, I'm about to invade the other side. So times x plus 2 times x minus 2, you can write again over 1, equals, I can do this, x plus 3 over x minus 2 times x, oh, I give up, right? I can't really stay on my side. Okay, so there you go. So from here, we are going to see if we can reduce. So x plus 2 is gone. X minus 2 is gone. X minus 2 is gone. So the remaining pieces are, over here we have x times x minus 2. That's one remaining piece. And minus x plus 2 times x plus 2 equals, over here, excuse me, I'm going to write the quantity around there, so we are mindful about distributing the x plus 3 to x plus 2 correctly. And from here, distribute this very slowly and cautiously. Ready? X times x is x squared. X times minus 2 is minus 2x. I'm going to write a minus down first and distribute that correctly and slowly. X times x is x squared. X times 2 is positive 2x. In the middle, another 2x, and 2 times 2 is positive 4. Then over here, x times x is x squared, x times 2 is now 2x. In the middle, 3x, and the last two terms, 3 times 2 is positive 6. Now let me tell you, the reason I put quantity around this is because I want to distribute this negative sign correctly throughout. Okay, so I'm going to copy these two things down first. Here we go. Negative x squared, because remember you have to distribute the minus sign to all of the terms. So now negative x times a positive 2x is now a negative 2x, Same thing with minus 2x and then minus 4 equals, I'm going to combine like terms. You have 2x and 3x in the middle. This equals to x squared plus 5x and plus 6. Okay. Now on the left side, let's see what happens. We have an x squared and a negative x squared. Those are gone. We have negative 2x here, negative 2x here, negative 2x there. So now that's a negative 6x's, okay? And then drop down your minus 4 equals to x squared plus 5x plus 6. So I'm going to move everything to the right side by adding its opposite. So add 6x, add 4. Whee, there you go. So over here, these are now zeros. Okay, so that's going to be 0 equals x squared plus 11x plus 10 equals 0. I'm going to see if it's factorable. So on the top is, on the top is 10. In the bottom is 11. Two numbers multiply give you 10 and 11. So that's going to be, I'm sorry, two number to multiply give you 10 and add give you 11 is 10 and 1. So that's definitely factorable. So x squared plus 10x plus 1x plus 10. We are going to, if you already know what the factors are, you can straight up write it, okay? Then factor by grouping. So 0 equals, take out an x, so you're left with an x plus 10. Over here, take out a positive 1, so you have an x plus 10. So your two factors are x plus 10 times a quantity of x plus 1. So let's take each factor and you set equals to 0. X plus 10 equals to 0. X plus 1 equals to 0. So your two solutions are negative 10 and negative 1. Well, let's go check again our restrictions and make sure we can keep both. Where were the restrictions written? Okay, so the restrictions were all the way up here, and here are answers. Yay, we can keep both because it's not, the restrictions were x can never ever be negative or positive 2, but we found x at negative 10 and x at negative 1, so we are good. We can keep both answers. Okay, so you're excited to take note on the last example of Unit 4? Here we go, okay. So here, let's do this. We have the denominator. Again, if you want to, you can put this over 1. Your denominator, first we want to factor. So we're going to write everything out in factor form before we do the denominator. So n over 1, n squared minus 5. Oh my, that is not factorable, okay? So n squared minus 5 over n squared minus 1 is factorable. We're going to write n plus 1 times n minus 1, because that's a difference of two squares, equals n squared plus n plus 2 on the top. We want to check if that's factorable. So what we're going to do is make an x. On the top, we want a 2. On the bottom, we want a 1. So this one said, okay, well, find two numbers when I multiply, give me 2, and add, give me 1. Most of you want to say, okay, 2 and 1, but that's not true. 2 and 1, when you multiply, give you 2, but when you add, definitely not give you 1. So this is not factorable, okay? So I'm going to leave it alone. So this is now n squared plus n plus 2. So that's left alone because it's not factorable. So LCD, are you ready? Looks like n plus 1, it's on each side, so I'm going to keep it. Looks like n minus 1 is all by itself, so it's also part of our LCD. So restrictions, ready? X can never be negative 1 or positive 1. So box that up. Then we are going to take each term and multiply it to our LCD. So n over 1, our LCD is x plus 1 times x minus 1. Do you want to put over 1? Sure. Do you have to? No. Then plus n squared minus 5 over n plus 1 times n minus 1 times our LCD, x plus 1 times x minus 1 all over 1 equals n squared plus n plus 2 all over n plus 1 times our LCD, x plus 1 times x minus 1 all over 1. Are you ready? And if there are numerators and denominators have more than one term, like that one and that one, you want to put it in quantities. Ready for cancellation? Ooh, the first one, I can't cancel anything, could I? Okay. So this first one is just as, why are there n's and x? Oh my gosh. See what I did? I wrote all the x's. Okay. I'll go back to the LCD and change them to n's. Sorry, I'm just used to writing all the x's. Okay, so n, and this is n, and this is n. You can change them to x as long as they're consistent. Because right now, I just realized I can't cancel any of my LCDs because they're x's. Okay, sorry. Okay, so x plus 1. Oh, see, I wrote x again. Darn it. N plus 1. N minus 1. N plus 1. N minus 1. N plus 1. I'm so sorry, guys. N minus 1. I'm just so used to x's. Okay. So now I've changed all my LCD to n's. Now we can cancel. So, but the first one, I realized that you can't cancel anyway. So write that over. Then over here, you know what this is though? If you remember, this is n plus 1 times n minus 1, and that's the, like that right there, and those are the factors n squared minus 1. So it's probably easiest for us is to, before we distribute, we want to write it as n squared minus 1, because it's going to be a little bit easier for us to distribute, right? So n squared minus 5 times this right here, our LCD is n plus 1 times n minus 1. And remember, that was the factors for, oops, I wrote x again. That was the factors for n squared minus 1. So it's easier for us just to write that down. Oh, but I can't, oops, sorry, I got so excited. This one is cancelable, I lie. N plus 1 can cancel n plus 1, n minus 1, n minus 1. So cancel that out. So the middle term doesn't have anything to distribute. Now the last one, let's cancel n plus 1, n plus 1. So the last one is n squared plus n plus 2. All of that is going to be multiplied by n minus 1. Okay, so now that I'm using all n's, let's distribute. Sorry, I was writing x's for a while, so that must have been confusing. Okay, so now this is n to the third minus n. Drop down n squared minus 5 equals, and this is the one you have to be very careful. N squared times n is n to the third. Okay, n squared times negative 1 is minus n squared. Now in the middle, n times n and n times negative 1. So n times n is going to be positive n squared. N times negative 1 is negative n. Let me get a different color to multiply the last term. Let's do purple. Nope, we already have purple. How about green? So 2 times n is 2n, and then 2 times negative 1 is going to be negative 2. So plus 2n minus 2. And now we're just going to slowly see if we can combine some like terms. On the left hand side, I have 1n to the third, and then 1n squared, a minus n, and a minus 5. There isn't much there for us to combine. Over here on the right, I have 1n to the third. Any n squares? Let's see. We have a negative n squared and a positive n squared. Those two are just going to cancel themselves out. Then we have a negative n and a positive 2n. So those will have a remaining of an n. And then drop a minus 2 over. So we are going to see, okay, so what happens is you have an nth on the right and an nth on the left. Those are going to cancel each other out. And then the rest of them, we're just going to move all of it to the left side by doing its opposite. So minus n plus 2. So, okay, so this side equals to 0. Over here, we have an n squared minus 2n and a minus 3. Now let's see if this is factorable. So on the top is negative 3. And the bottom is negative 2. Find two numbers when you multiply gives you negative 3 and add give you 1. So that's going to be a negative 3 and a 1. So let's rewrite that. N squared minus 3n plus 1n minus 3 equals to 0. You want to factor by grouping. So take out an n, you're left with an n minus 3. Take out a positive 1, you're left with n minus 3 equals to 0. So your factors are n minus 3 times n plus 1 equals to 0. Then take each factor. So n equals to 3, take each factor and set equals to 0. Oops, n equals to negative 1. Let's go back and check our denominators to see if the exclusions is something we can keep. All right, so in our exclusions earlier, after I fixed all the x's, sorry again for that, we said n can never ever be, let me just highlight that for you. Earlier we said, okay, well, n can never ever be negative 1, see right here, okay, negative 1 and positive 1, and we came out with an answer that says n is negative 1, so that one we cannot keep. We are gonna go and eliminate it, okay? X it out, ready? Wow, okay, so final answer, you can only have n at 3. So only n equals to 3 is when we can make the original question a true statement. And guess what, guys? This is the end of Unit 4.